All right, we're going to go ahead and add, subtract, multiply, and divide functions. So the first one is adding. So you're adding two functions together. Second is subtracting two functions. There's your notation. Third one is multiplying two functions together. Here is your notation for multiplying two functions. And the last one is dividing. You do need to make sure that when you divide those that you do not want that denominator to equal 0. Pay attention to your domains of your functions, so they're in common with both. So here's an example. We have a function f of x. It's a linear function. And then we have a g of x function, which is a quadratic. And it's asking us to add the two functions together. So we're going to take 2x minus 1 and add it to x squared plus x minus 2. So when we add these two functions together, we can just go ahead and drop their parentheses and combine like terms. So 2x plus x is 3x, and then negative 1 minus 2 is negative 3. So this is adding the two functions. What we get is a quadratic function. Now, if we think back to linears, the domain of this linear function is all real numbers. This is a parabola. Its domain is also all real numbers. So now notice the new function is going to also have a domain of negative infinity to infinity. All right, example B, subtracting. So we're going to take 2x minus 1, subtract it from x squared plus x minus 2. So we're going to drop the first parentheses, and then we're going to distribute a negative through all of those terms in the second parentheses. Now we combine like terms. And what we get is a new quadratic function. The domain of this function is also all real numbers. Part C, multiplying the two functions together. So we have to distribute the binomial to the trinomial. So we're going to take 2x and distribute it. So there's distributing the 2x. Now we're going to distribute the negative 1 to the second parentheses. And then we put it in standard form, combining any terms. So here is the product of those two functions. It's a cubic function. It also does not have any domain restrictions. Continuing on with part D, we're going to divide the two functions. So we're going to take f and divide it by g. We do need to factor that denominator. So we say, what are the factors of negative 2 that add to positive 1? So here it is in factored form. There are two domain restrictions. We do not want the x to be negative 2 or positive 1. So it'll be all real numbers except for x cannot be negative 2 or positive 1. You could also write it as interval notation, negative infinity to negative 2, or negative 2 to 1, or 1 to positive infinity. Example of adding and subtracting. Actually, this one just is an adding problem. So we have a square root function and another square root function, and we want to add these two functions together. Remember, when you have square root functions, you do not want that radicand to be a negative. So I'm going to set it greater than or equal to 0. I'm going to solve it for x. So this domain restriction has to be greater than or equal to 0, greater than or equal to 3, excuse me. The second one, x minus 2, has to be greater than or equal to 0. We're going to solve it for x. So here are our two domain restrictions for those individual functions. Now let's take care of a. We're going to add the two functions together. You can't combine these two square root functions together because their radicands are different. So that's your final answer. But now we do have those domain restrictions right here. So if we think of that on a number line, here's negative 3. We need it to be greater than negative 3. And then here's 2. We want it to be greater than 2. So our final answer for our domain is everything has to be greater than or equal to negative 3, because both of those would work. So here is your domain. I do have it graphed out with the graphing calculator. Here's what the graph looks like. And we're starting at 2. Oops, this should have been a 2 here, sorry. So you can write that domain as x is greater than or equal to 2, or as an interval notation starting at 2 to infinity.